All right, and next we have Zhichao Guan from Peking University, who will be talking about semantic lifting for syntactic sugar. On to you.
Thanks for introduction. Hello everyone, I'm Zhichao from Peking University. Today I will present our work, semantics lifting for syntactic sugar. Syntactic sugar is a widely used tool in language engineering. It offers convenient syntax and high-level abstractions, which is suitable for DSL implementation. Such a DSL can be defined as a collection of syntactic sugars built on top of a general-purpose language as a host language. For example, E1 and E2 can be defined as if E1 then E2 else false. Here we use arrow D to represent the desugaring rule. However, sugar-defined DSLs face a problem. Consider a user who is an expert in the target domain, but unfamiliar with the host language. After writing a DSL program, the code is first desugared into the host language before dynamic execution or static analysis. If an error occurs, the error messages will be framed in terms of the host language. For the user, to understand these messages, he has to learn knowledge about the host language, which can feel like falling into a black hole. This issue is known as abstraction leakage. To solve this problem, previous work proposed the idea of language lifting, which means that given the syntactic sugars to define the DSL and the complete definition of the host language is semantics, typing rules, and other things, we aim to lift the DSL definition according to the syntactic sugars and the host definition. We expect the DSL definition obtained preserve the abstract boundary, which means that for any DSL program, its execution or analysis doesn't touch the host language anymore, and everything is understandable to the DSL users. The typing rules for the DSL have been successfully lifted by previous work, and the abstraction property has been proved. We can find in the lifted typing rule of and, host language construct if is not mentioned anymore. Naturally, this raises a question. Can we use a similar method to lift semantics? And can we ensure abstraction in doing so? In the case of and, it's OK. And we'll soon demonstrate how the derivation works. However, after further exploration, we found that directly applying the type lifting method to semantics lifting can easily result in the abstraction leakage. Informally, this is because the semantics definition often involves some non-local and non-conversational evaluations. Such complexity makes the abstraction preservation in semantics lifting more challenging than that in lifting typing rules. And we will explain this later. So our work proposed a set of reasonable conditions, imposing certain restrictions on the syntactic sugars and the host language, ensuring that within this framework, the semantics lifting preserves the abstraction. So next, I will first walk through the algorithm using the AND example. And then, based on this algorithm, I will explain the challenges of preserving abstraction in semantics and the tools we will use to address them. After that, I will introduce the conditions we propose. And finally, I will introduce the implementation and evaluation of our system. So first, the algorithm. Note that the algorithm we use is very, very similar to the type lifting, and it's not our main contribution. The algorithm takes two inputs, the host semantics and the syntactic sugar. We use big step operational semantics in our framework, and the output is the DSL semantics. For the AND sugar, first, E1 and E2 should be evaluated to a value v if the if expression is evaluated to v. And because we know the rules of if according to the host definition, we can apply these rules and expand the premises. There are two possible cases. And in the red tree, false is a value, so we can expand the premise further. Then, by removing the intermediate derivation and simplifying the result, we can obtain the following evaluation rules of and hide the host language construct if. That's how lifting algorithm works. Briefly speaking, if we want to derive the evaluation rule of the sugar C. We just need to find the derivation of its random hand-side expression in the host language. Here, an important observation is, if all the evaluation rules in the host language are structural recursion, which means that the result is always premised on the values of its sub-expressions, then after we define syntactic sugar, the intermediate host construct in right-hand side will be stripped away step by step. And finally, the premises will only contain the evaluation of these variables, thereby preserving the abstraction. This property is generally satisfied for typing rules, but not for semantics. So the next step is to break down the non-structural parts of semantics, and we will introduce some gadgets to describe to capture them, and our conditions will be defined on these things later. The first is non-locality, which can be seen in the rule of lambda abstraction. It keeps an unevaluated expression in the result. As a consequence, when lambda abstraction is used to define a syntactic sugar, the body cannot be derived statically and locally because it itself is a value. And if we derive the evaluation rules for and f like before, we will get this. And here, if appears and the abstraction leaks. Such non-local evaluation may cause the abstraction leakage. And to describe such non-local evaluation, we call this E, this body, the non-abstract component of the lambda abstraction. And we design analysis to find these non-abstract components automatically according to the host language evaluation rules. If a host construct is used in this position in sugar definition, like and f, we will reject such syntactic sugar. Actually, it's one of our conditions. The other one is non-compositionality, which can be found in the application rule. There is a premise which is not a simple evaluation of its sub-expressions, and it contains a substitution. To isolate these non-compositional parts from generic evaluation, we introduce the concept of meta-functions. Meta-functions can also be used to express primitive computations and operations on set effects. And then, we reorganize the rules of the host language in terms of evaluation and these meta-functions. We will propose the conditions of meta-functions that say, if these meta-functions have certain properties, the overall abstraction property can be guaranteed. Now we can introduce our conditions. Of course, since we have introduced meta-function as a form of judgment, we have to make slight modifications on the semantics-lifting algorithm a bit. Due to the time limitation, I won't go into further detail on that here. We have proven that, informally speaking, correctness and abstraction can be guaranteed under the conditions we provide. Here, correctness means that if E is evaluated to V in the lifted semantics of DSL, then DE will be evaluated to DV in the host language. Here we use big D to represent desugaring. And the abstraction means that for any DSL program, the derivation tree of its evaluation doesn't mention any host language construct. And additionally, we introduce a set S to describe the value constructs that are permitted to appear in the DSL. There are 4 conditions. The first 2 are about meta-functions. Meta-functions doesn't generate host construct out of thin air, and meta-functions and desugaring are commutable. The third one is about the host language semantics. We require that rules of the host language use no other host language construct in the premises. And the fourth one, as we stated, is about the syntactic sugars. Syntactic sugars uses no host language construct in non-abstract components. Among them, there are 3 conditions are about the abstraction, and one is about the correctness. And the important point is that only the condition related to the non-abstract component, the fourth condition, concerns the DSL designer. The remaining conditions are about the host language and the meta functions, which are predefined. And that's not something the DSL designer needs to worry about. There are many interesting implications from these four conditions. For example, hygienic problem, which is a famous problem in microsystem, is related to the second condition. And if loops and recursion are used in the desugaring rules, these two conditions can guarantee that the termination of the semantics lifting. And I cannot cover all of them now, and more discussion can be found in our paper. So now it's time for evaluation. We have implemented our DSL development system in Haskell, named Osazone. And we provide two basic host language, Lambda Calculus and MiniML. And we implement some extensions based on them by introducing some new data types and effects like references, I/O, and exceptions. And Osazone provides an interface to define DSL using syntactic sugars, and the semantics will be lifted automatically. After that, Osazone will generate an interpreter and IEPL for the language for free. To evaluate our system, we focus on whether Osazone is expressive enough to develop DSL, and whether the lifted semantics protects the abstraction boundary. To answer the first question, we collect 7 benchmark DSLs from the samples of MPS, and we produce them in Osazone. And we implement 5 more real-world DSLs. To answer the second question, we show the number of the syntactic sugars to implement these DSLs, and we check the lifted semantics manually. To sum up, in this paper, we propose a framework for lifting semantics for syntactic sugars, and we present a set of reasonable conditions to ensure that semantics lifting will guarantee the correctness and the abstraction properties. These conditions are imposed on meta functions, host language definitions, and syntactic sugar definitions. For this idea, we implement the tool Osazone, which is shown to be flexible and practical for developing DSLs. And if you have any ideas about the language lifting, I would love to discuss with you. And we also will show our work in the poster session. That's all. Thanks for listening.
Thank you for the very nice talk. Have lots of time for questions. Yes, please.
Yeah. When do these correctness and abstraction properties fail on some? I understand you had all those examples that worked, right? But I don't quite understand the boundaries of like what DSLs would fail these conditions. So when would we be in trouble with your framework with a certain DSL? That makes sense.
I'm sorry, maybe I cannot get the point of that question.
So go to your table where you have a bunch of benchmarks you ran. Yeah, so were there any other examples you tried which failed?
Actually, no.
Okay.
We designed some DSLs in our framework, and we found that all these DSLs satisfy the properties we want. And actually, maybe you want to say, there are some number in here. And actually, these sugars doesn't satisfy the fourth condition. And at this time, we will have to introduce some auxiliary constructs.
Okay, that's what I want to know. Great, thanks.
Thank you. Other questions?
Hi, thanks for the talk. I didn't quite understand what was wrong with the desugaring of end. Earlier, you showed that it's leaked the abstraction. So, in the context of a lambda, right? So. Yes. So what was wrong with this desugaring? We desugar end into an if, right?
Yeah.
And then you said that if there's a lambda, you have a slide that shows the lambda x e.
Yeah.
Then you said something was wrong and the abstraction was leaked, but I didn't quite get it. Yeah. So yeah. Yeah, this one.
This page, right?
Mm-hmm.
Uh,
So what's wrong here, and how can you fix it?
Actually, this NF cannot be defined if a language doesn't contain if or and or any other similar functionality in the language. So if we so what you want to ask is why this evaluation rule is wrong? Because this evaluation rule after we write an NF in the DSL program, and this NF will be evaluated to the right expression, and this contains an if. And this if is not program the DSL programmer writes. He doesn't write any if in his program.
Yeah.
Yeah, and in our example, we suppose that the DSL programmer doesn't know what it is. He only knows what is n.
And so what's your solution? How do you fix this?
Actually, we want to say that this is a problematic syntactic sugar, and it's not the.
So you cannot desugar n into if.
To do this, we have to introduce some auxiliary syntactic sugars and to factor out this body. For example, we can define. Actually, I think I have.
Yeah. What's the solution look like?
Yeah. Start. So we have to introduce the auxiliary language construct, this and f prime, and this n prime is same to the n, and we have to redefine this n introduce this n prime. And
Okay.
because this n prime we consider as a language construct of DSL, so DSL users can understand this. Yeah.
Okay. Thanks.
Any other questions? All right. If none, let's thank the speaker again.